Well, hello. How's it going? What's up, everybody? It's Liv. Today I'm just going to quickly summarize the process, the progress that we've done over the last few days. It might not look like much, but it's been quite a lot. It's been quite a long time coming, and we know what change is gonna come. So anyhow, let me first and foremost play some music here. So who's going to play the arena soundtrack, the beloved arena soundtrack composed by Eric Haveling. Uh, Go have a listen at it yourself. It's good stuff. So anyhow, with that in the background, and actually I should have made it. There we go. Okay, so now I can actually use this console. Anyhow, I'm gonna go into the R folder. Okay, so this is the other project folder. Let's say this is where most of my projects are, these related projects. Okay, um and we're gonna take a look at what we have in here, and we were working in some kind of menu. So behind the scenes I went ahead and ironed out some of the kinks that this menu had, and yeah, and we're still showing the cursor just because it's convenient to have it there for now. And as you can see, we have a list of options, and we can just cycle through them, right? So it's pretty good. This is functionally a menu, right? We still need, to enable entering into one of these options and things like that. But it's a starting point, good enough. Besides this, we've also worked in a little dialogue kind of thing, and for you to fully appreciate it. Oops. And for you to fully appreciate it, I'm gonna have to move my face here a minute. Okay, so let's get back in here and let me play this for you. Okay. And as you can see, it's like a very basic kind of old school RPG dialogue, and it's pretty cool because it pauses at different punctuation marks, as you can see. So here at the exclamation mark it stops, at the semicolon, at the commas a little, and at the dots. It's actually pretty cool. And when it completes the page, it does this little animation over here. So that's actually kind of nice. And if you press enter, it goes into the next page, and and your epic adventures start, right? So anyhow, that's a little bit of what we've been doing. And the key at the center of all of these progress is the Lycon library. Okay, and Lycon, it's basically a set of console utilities, so to speak, right? And it actually comprises several libraries, not just the Lycon library. But for the most part, it's what giving us most of the low-level keyboard access that lets us detect key down, key held, and key release events on Linux, right? Not over an SSH connection, because obviously we don't do that kind of crazy in here. But, if you're doing a desktop like you should, and want to play some games or want to write some games, right? This is all you need, right? And so, okay, one problem we have is that actually I need to open up two files to show you this. And this is in CTL, not control. Okay, so it's the same thing but spelled differently. Anyhow, the way that Lycon works, it's by replacing the subroutine calls in a loop, right? So this draw is actually a getter, or so to speak. It's a getter that will run a subroutine that you have saved to this particular slot, right? And so what I was doing is I was adapting a lot of functions to work within this loop. And one of the ways that we do is we do this thing that I call, transferring control, because that's basically what's going on. You're giving control of a loop to a particular module when that module is the one that decides what are the subroutines that the main loop will be running, right? And so those two subroutines are logic and draw, okay? Simple enough. And there is a problem, a singular problem, which is actually not so self-evident when you look at it, but it's actually kind of a problem. So I wanted to make it so I could redefine what a certain key was doing, because the way this works is through callbacks, right? So you press a key, and that has three events, right? So like I said, key down, that's the moment you tap the key. Key held is when you hold down the key for more than one frame. And key release, what happens when you let go, right? So rather than having within these subroutines, having a lot of evaluations in order to know what to do depending on the context, what I do is when I enter a new context, I just bind a new subroutine to that slot. It's something we can do. Lycon has been more or less based on this kind of system, where if you want to change what a key does, you change the function pointers attached to that particular event. And it's not quite as straightforward as just doing one routine, right? If you do just one function for each key, that's more straightforward and less confusing, but it's not quite as efficient, right? So that's the key here. It is not quite as efficient, and that is what I want to focus on. So what I'm gonna do is I'm gonna take care of this one problem that we have. Whenever we enter a new context, that's what I like to call library side, lib side. And for this library, we require some keyboard access. Well, the initial binding of these keys should be up to the application, not the library, right? So you shouldn't, when you write an application, you shouldn't be having to check what are the names given to a particular key. You should only care that the internal name of the key is in use, meaning that your application declares this key as being in use. So is that a little bit confusing? Let me further explain. If we go here into the keyboard initialization, the way this works is you say, I have a user given name, and this is simply for a reason, because you might want to say that space is the jump key, right? If you want to do that, you should be able to do that. So we have user given name, and then we have the keylay name, which is the internal identification of the key. So this is the actual name of the key at the level of the low level implementation. So you need to have both things, but this becomes a problem, because once you want to utilize the same low level identificator, in two different modules, then there needs to either be a consensus on what the user given name is, or the library level module utilizing that key needs to care only and only about the keylay mode, and just let the user name the key whatever they want. So here's the problem. Whenever we define a key library side, rather than passing this name as it is, what we need to do is use this name solely this name. And so that means we need a new hash table. And the way I'm gonna do it is I'm just going to say my ID keys, right? So because this is the low level identifier of the key. So what we're going to do is whenever we define, first and foremost, we're going to check for the hash key, which I shouldn't have done before and I forgot about it. So hash key, basically this will return an error if the key is in use, and actually it should exit. Perhaps we should try and fail gracefully here, but we'll get to that in a minute. Anyhow, besides this, we also need to utilize a hash ID, HASID, as it were. So basically we pass the low-level ID that we're trying to define in here, or that we're trying to see if it is defined. And actually, you know what? It should actually, let me do it like this. And then I'll handle the failing, because if I just exit outright, it's not going to be so good. Okay, so let's do this properly, right? And what we're going to check for here is if within ID keys, we have this ID declared, right? Exits, exists. If we do have this declared, if we do not have this declared, then what? Well, we're just going to let the user know, first and foremost. We're just going to do a straight up printing, and we'll handle the error at a later stage. Key ID is not registered, was not registered. It's not. So I just got a message. Give me a second here. Okay, so it's just spam. All right. So anyhow, what we want to check for this particular control take is that the ret and space keys are in use. So what we have to do actually is we have to do sort of a begin, so to speak. What we could do is simply say Lycon keyboard ACID, and we want to repeat this for every key that we need, right? So the keys that we need what I'm gonna do, I'm sorry if I'm not making much sense, but I'm thinking as I go. But anyhow, what we have to do is whenever we fail to find a given ID, we need to register it. Else we need to fail, right? So what I want to do is, if HASID, so if we already have this defined, then we want to fail, and I'll handle that failure at a later stage, or maybe I'll handle it here, I don't know. But when we do not have this thing defined, what we want to do is go into our ID keys and register the ID to equal the key. So pretty simple. Just like that. Yeah. And so then, whenever we want to redefine whatever is bound to this particular ID, we can just fetch it from here, right? We can just fetch it from here. And so I want to say, I want to redefine whatever is being used for the return key. Then I can just say, I suppose, yeah, I suppose what redefine should do is, rather than take the user given name, just take the defined name. But I would like to have access both ways, right? So what I'm gonna do is I'm gonna make a redef2, right? Which is going to be essentially the same function, but it's with a different kind of access, right? So it might not be the most intuitive way, but you know, we basically want to do the same through different means. If you get my, if you get what I'm getting at. Okay, so and actually, yeah, right. Okay. Oh, well, shit. Okay, so this is what I'm gonna do. Because this is a little bit of a philosophical question that kind of you face in this kind of situation. So I want to prohibit redeclaration, right? Or rather redefinition. No, redeclaration is more the better way to say it. So I don't want to have two keys utilizing the same IDs, right? I don't want conflicts in that area. So it's a weird thing to check for, right? It is a weird thing to check for. How should I go about it? Because when it's simply one identificator, so in this case, right, so when I'm defining, I'm not going to throw an error, right? But because if I throw an error when I'm defining the key, if the key doesn't exist, that's counterintuitive, right? It will always throw me an error when I'm trying to make the key exist, right? So that's not what I want. But right, yeah. I need to handle this more responsibly, no? So if not has key, right? No, you know what I'm gonna do? I'm gonna half-ass it. Okay. So I'm gonna half-ass it. Okay. So we know this kind of getter, we want to do it two ways. And it's not actually going to be a getter, it's more like an error check, right? So an error checker. And what I'm going to do is I'm going to invert the error throwing, okay? So if the key doesn't exist and the check is not inverted, then we exit. And yeah, I realize that probably I should leave this exiting to another function. And so what I think I'm gonna do is I'm gonna define just a dummy here, and I'll work it out as I go. Okay. Let's say exit. I'm gonna say fatal. Yeah, I like fatal. Okay, and fatal is just for now only going to be exit, but as we develop the error handling, we'll be able to work on it. Okay, so Lycon fatal. All right, and that's all we need to know. Okay. Else if this exists and it is not inverted, meaning we want to throw an error if a key exists, then we also Lycon fatal. Okay, and what changes is the error message. So actually what we should do, I should make some constants in here, since I'm going to be using probably the same error messages for a bunch of how do you say, for a bunch of cases, right? So let's say RMS, RMSs. I'm gonna say use constant, and e no key oh, this is problematic, because if I want to do interpolation, what I could do is a 0 key such and such, is not defined, right? We can do that. Yeah, that's nice. And I'm actually going to wrap it in brackets, in angle brackets, as they say. Angle brackets. Yeah. So okay, the message is simply going to be in no key 0 and key in no key 1. Okay, we pass that to fatal. It's nice. So yeah, but there's probably a better way to write this, but actually, I know. Actually, I know a better way. I know a better way. Hell yeah. So I can make this sort of a placeholder format, right? And then fill it out. So I have to, okay, so to fatal, we have to pass a format and a list of, right, so it's basically a printf that leads to an exit. Okay, so perfect. No key, yes key, okay. All right, and there you go. Okay, nice. So because this is going to be the exact same, the only thing that differentiates them is the, here we have the word key, and in the other one we would have the word ID. So you know what? Let's do it like that. And what I'm gonna do is to this we're going to have to pass the hash reference, right? Now, which hash reference you want to error check. Or you know what, actually, what I can do is make this sort of like a prototype, right? So we have one function, and then from that function we spawn others, right? So proto, and that's a nice way to say it. proto. So key would be shift. Then we also need the is the check inverted, all right? And last, what we need is what else do we need? Actually, I can make this a string. Yeah, I'm gonna show you a cool little trick, okay? Yeah, don't tell nobody I show you this. But okay, so I'm gonna say our proto, and I'm actually gonna say my because I'm feeling a little bit lazy. But this is actually going to be a string, okay? I'm gonna say oh, I guess without interpolation, that's nice. And so because what I want to do is to sort of convert this. Okay. So actually, let's do a little bit of this. And we'll sprintf this thing, okay? All right. Okay, now, so key should be shift and emb should be shift, but my hash reference, right, because we're doing the same operation on different hashes. I'm sorry. This kind of twisted sort of programming sometimes gets to my brain. So anyhow, the check is just this, right? And then on this side, we just do the proto, and we pass in the inv key, right? The key and the inversion, but not everything else, right? Because this should already be defined. Okay. The way this is going to work, I'm actually, you know what? I am going to have interpolation so that I can actually tell so the way I escape the dollar signs, what basically telling me is that this is paste here a literal dollar sign. So because what we're going to do is, this is a string, and from this string we're going to sprintf it into different subroutines, right? So we're going to evolve sprintf into evolve into a different subroutine, right? So we're going to generate code. Basically, this is now meta programming 101. Okay, so here we have another thing we need to pass, and that is the error message that we want. Yeah, same story. We need to check for the. Actually, we can do this check once. My has again, if not has. Okay, so that shortens it a bit. All right. So the two things we need to pass is the name of the hash reference, the name of the hash we want to reference, and right. So if I'm going to make it a reference, I should actually do it correctly. Yeah, that's more like it. Okay. So we need to pass the name of the hash we want to reference and the names of the two errors, of the two possible errors. And then Lycon fatal is just going to be a printf into an exit, okay? So fatal, and we have a format, that's shift, and then it would be printf fmat and everything else we've passed. So there you go. You know, people talk a lot of crap about Perl, which, you know, fair enough. It's an obtuse, terse language. But this kind of thing, perfect. It's perfect for it. That's why I love it so much, you know? I could do things like this in Python, and I guess I could do them in Ruby as well. But Perl is just a natural fit for this kind of bullshit programming, you know? And I mean, yeah, fair enough. Like, I shouldn't call my own hard work bullshit, because I can assure you it is not. This requires some intellectual engagement on my part. But yeah, it is not a straightforward kind of programming. That's what I'm trying to get at. This is weird type programming. It's meta programming. Okay. Why I put two semicolons before the name here, just so it will match here the columns. I'm a little bit paranoid about that kind of thing. I don't know exactly why. How it started, I have no idea, but it happened. And actually, I need to cut at end of. Okay. Let's make it end of. And I am, say tuk-tuk. So, tuk-tuk, end of, and that's a wrap. Okay. And I'm gonna do the same thing here. Or maybe not. Yeah, because this is something different, right? Yeah, that's fine. Yeah, that's absolutely fine. Okay. So now what we can do is generate these two subroutines, okay? So what I need to do is to say evolve and all of this as a string. I guess I could do both, right? Yeah, why not? And so the difference would be it's different sprintfing of the army proto. Okay. Sprintfing. So all right, because this is already included. Huh. Wait up. Give me a second here. Because I know that I want to say sprintf, and this is the string giving me the format. So what now? Actually, I shouldn't double those formats. I just realized this is what you do when you want a literal percent sign on the string. When you do it like this, it's because you want to do interpolation. or formatting, if you will. So all of this is a multi-line string, right? So now what we want to do is replace these symbols. Okay. So for the first prototype, I know that the first string would be what is it? Keys? No, it's the hash for keys, right? And indeed it is. And the second one is ID keys. Okay. I'm gonna say KIDs because it's the K IDs. Okay. All right. The key IDs. Key IDs. Key IDs. Okay. So we use no key and E yes key. Okay. So I need to have a sprintf within a sprintf. That's fine. Okay. The first element is keys, and the second one is going to be E no key, E yes key, and I have to pass in your key and the name, the particular name of it. Okay. Oh, right. So this one is going to just be there. Well, shit. Well, I could just pass it in here, right? Yeah, that's fine. So actually, we don't need to do a sprintf within a sprintf, which is a little bit ridiculous. Which means that actually, I can pass it like this. And what I actually need to pass is this type in here. That I can pass that in, right? Okay, so that's just 2. Okay, I'm going to say key, and so now it will replace the first thing in here. At the time of Lycon Fatal, it will replace that first one with key such and such not defined, key such and such is already defined, and there you go. Okay, so actually this is just that, and it will replace this thing here and this thing here just like that, no problem. And there might be a better way to do it, likely, but what you gonna do? So anyhow, there's likely a better way to reuse the strings in here, but you know, I'm not going to worry about it too much. Anyhow, what I guess I'm going to do is I'm going to try and define these two subroutines, and then I guess I'm going to, on a separate scope, I'm going to evaluate them to something. Actually, I could do all of this in a separate scope, so I don't have this prototype laying around. But it's not the worst thing to have laying around, you know? Okay. Oh. Check it. Isn't that beautiful? This is what I want to do. Right. So now can just evolve this, right? So the first thing I have to pass actually is the name of the function. So in this case is haskey. In this case is hasID, key IDs, and we're going to say key ID. I'm going to say bound. Okay. All right. So, you know, you might not be able to follow along because of how confusing a lot of this is, but if it works, it works, you know. So yeah, okay. Let's do it. Okay. All right, so now I can say haskey, and if the check is not inverted, it will fail. Right, it will fail only when the key is already defined, and I'm trying to define it. So this is something you should only call when you initialize the key, when you say this application wants to utilize such and such key. In this case, this thing should pop up, right? Likewise, we should do a check for the ID. So has it, right? And has it, likewise, it needs to fail if if it is already defined and the check is not inverted. Okay, so same deal. Okay, so as you can see, with a single entry point, I've basically dealt with 4 different errors. Okay, so that's nice. This is as you can see, this is the least straightforward way of doing this. This is the least straightforward way of doing this, but no, check it. We are generating our error messaging, right? Or error handling, we are generating it. No need to worry, right? So if this becomes incredibly horrible to debug, well, you know, I'll take full responsibility for that, right? But since I'm the only contributor in this entire code base, which spans tens of thousands of lines of code, then, you know, at this point, you know, it's not something I'm afraid of to take on such responsibility, right? So okay, let me check. Okay, so I've been at it for almost an hour. So oh, one more thing. Okay, good. So so we have the checks down, and I'm actually going to refresh my head for a second here. Excuse me. I shouldn't do this, right? So I should cover my head, but yeah. Anyhow. But anyhow. I don't know where the tradition begins, but the tradition is their head should be covered. That's not something you can walk around. Okay. So anyhow, I now need to refresh, so to speak, sort of the error handling here, because I was using the bare bones version of haskey. So in this case, it needs to fail if the key doesn't exist, right? All right. And so readef2 needs to fail if there is no such ID, right? So this is where the two functions diverge, so to speak. So in this case, you want to wait up. No, when I invert it, you see how this is confusing, right? So if it exists and it is not inverted, then fail when the key is there. So actually I need to invert this one as well. Okay. But these two diverge in that we try to redefine already existing, right? So this is what this one is emphasizing. They are similar in that they both fail when the requested key is not found, but what they diverge is how the key is being found. So there's so what this one does is it gets the name of the key by name, by its user given name, and then redefines the processes bound to it, the subroutines bound to it. And then this one has to get that ID. And from the ID, you can get the key. Okay, all right. And then from the key, you can get the index into the callbacks array, and then redefine the callbacks. Okay. Same access by internal ID. Okay. So I get that this is very confusing, but you know, this is what I have to wrestle with, you know. So okay. And what we should do is we should return the key, right? Now let me check in here. I need to do this differently probably. Or I guess what I could do. Huh. Yeah, rather than doing all of this. Right. Am I stupid? What I should do actually. Key by ID. Okay. All right. So, right. So what am I thinking? Right. What am I thinking? Okay. So because what we need to do is we need to save the definition of the key assigned to ret, right? But we cannot sbdef by ret by the internal ID. We need to use the user given one. So actually, I should handle this. I should have a method to handle this case, you know. Save and redef. Save and redef by internal ID. Okay. And so this one is related. Okay. So sub sb by ID. All right. And so it takes an ID, it shifts it. My key would be key by ID through this given ID, and I could actually just shift that, but never mind. then we have to redef by this key with the given list. Right, but first I need to save that. Right. So my callbacks would be sbdef by key, right? As opposed to by ID. So sbdef, I get the calls, then I can redefine with the calls that I provided. Redef is right here. Okay, so it actually needs to be a list. Okay. So everything else sent in here, go through here. Okay. And I should return the calls. But in addition, I'm going to return the key as well. Okay. So key and the calls. Okay. I'm going to have an SB LD by ID. Store previous def by internal ID. All right. So that's what. Okay. And we get my ref and my key equals ref sub 0. I love saying that. And my calls would be ref sub 1, which is not quite as cool as sub 0, let me tell you that. So this one I need to call. No, I'm trying to LD. Right. Okay. So I can just call it like so. The def calls key and calls. Okay. So now another problem arises. We can know. So I mean, you as an application developer, you can know which keys you want to use, but you cannot entirely know which keys the libraries you want to use. So that's another problem. And to be entirely honest, I don't have a solution for it. You'll have to read the docs, and that's that. What's the acronym? RTFM? RTFM. Read the fucking manual. That's the golden rule in this parts. Okay. Obviously, we could make it so certain the internal IDs that the module wants to take a hold of can be changed at runtime, right? We could do that, but that's a different story, and I'm not going to get that. I'm not gonna get into it right now. I'm gonna look at it at a later date. But it's something in the back of my mind. So don't worry, don't fret about it. So anyhow. What I need to do now is B by ID and SB by ID. Right. And so now I don't need to know what the user wants to call these keys. Right. So that's nice. And I can just say Key-Redef key space, right? So I get the right. So from here, from SB by ID, I get the name, the user given name for that key, and so I can just redefine it without knowing what its real name is. What you know, so that's nice. And I guess I could I do guess that I could just do that here, but since I already wrote LD by ID, no, you know what? This one doesn't need to exist, right? Yeah. Maybe if maybe at a later date. Huh? I can actually just Key-Redef. Space. Okay. So let's actually check that this works, right? Because as it is now, we don't know. So the way we do, I have a test ready for this. Okay, so SB by ID, right? So it's undefined because I need to rebuild this. Okay, no problem. I need to go automat and run my setup script again. Oh, you're talking about Willis? Okay. Okay. So now let's run the test again. And that doesn't work. Okay. Okay. So I must have forgot to escape the inverted at some point. Yeah, exactly. Oh yeah, right. I need to rebuild. Yeah, this is a little bit of the problem, but okay. So ID key is reversed with the packet name. Oh, because I'm still using ID keys. Right, no, this is key IDs. Try that again. Okay, so I have a problem. Right, let's see. Unmatched curly brace. That's something that happened here. What the hell? Let me just open the source, be done with it, and leave Lycon PM, and it says at 354. Okay, 354, and oh, right. Okay, so that's my bad. That's okay. Haha. Key-Redef is already bound, and that happened in the redef. Okay. Okay, so let me read this for a second. Okay, so, the good thing is, this means that this error message, error handling function generation actually works. So that on its own is good enough. But it's not working quite the way I wanted. So let me think about this for a second. So if it doesn't exist, and inverted is 1, then it needs to throw this. And that's not what happens here. No, because it's saying that it is already bound, right? Yeah, it's already bound, so it's giving me the yes, we do have this key. So it has and not, right? So this is happening at the redefinition. But oh, when I'm saving, right? Or is it? Let me check all the instances of hasKey. Okay. So I need to throw an error. I think I need to pass a warning, yeah. Yeah, there we go. Okay. So if I press the key, it does what it has to do. And okay, so the rebinding of the keys works because I know that because in here I'm defining these keys to do nothing, and inside the when that little speech thing runs, it works. So good thing what I set out to do actually works. So that's perfect. Anyhow, let's check Tron. Let's just make sure that, what am I? So Tron. Okay. And this one works as well. So perfect. Okay. So all of it works. Nice. Okay, so I guess scratch that out of the to-do list, right? Okay, so next up, need to be working on some other things, but yeah, this just a short session to show you a little bit of that. Okay, so yeah, stay tuned for the next episode of Making an RTS. And that's it for me. Have a good one. Bye.